Number 33. If a nut and bolt are difficult to undo, it may be easier to turn the nut by using a longer spanner. This is because, okay, let's assume that we have a nut like this. Assuming that, suppose we have a nut like this, and we have a spanner. Open it. Suppose the span. Okay, we have a spanner. Suppose this is a spanner and this is the handle. Okay. What it states that suppose the handle of spanner is of this size. So you know that suppose if you apply some force on it, suppose you apply force in this direction, then the spanner will turn. There would be a movement in it because force and distance are perpendicular to each other. Then there would be a turning effect in spanner. That turning effect will try to turn the nut bolt as well. If the size of the spanner is small, the rod is small, means the more force is required because the turning effect for a nut bolt is constant. Okay, if we increase the size of this nut bolt of this spanner, suppose I'm going to make it like this. Now we know that the turning effect is same, and when turning effect is same, if you increase the size of rod, perpendicular distance increases and force reduces. Initially, it would require a large magnitude of force, but when you increase uh, the perpendicular distance, it eventually reduces applied force. Okay. Okay, now that the question is related with this thing, if a nut and a bolt are difficult to undo, it may be easier to turn the nut by using a long spanner. Because when you have a long spanner, you need to apply a small amount of force. This is because the longer spanner gives a large turning effect, small turning effect, less friction, more friction. Friction is not linked with it. There is no connection of friction in it. So when we have a longer spanner, the long turning effect will be generated. So we can easily open it. So our option is larger turning effect is generated when we have a large spanner. How much energy would be released if this 1 into 10 to the power minus 20 kg of matter was entirely converted to energy? So the speed of light is this one. We know by Einstein's equation E equals mc square. Mass is 10 to the power minus 20 and speed of light is 3 into 10 to the power 8, and there is a whole square. Okay, 10 to the power minus 20 is there, and we have 3 square is 9, and 10 to the power 8 is 10 to the power 16. So the result is 9 into 10 to the power minus 20 plus 16 is minus 4 joules. So the correct option is this one. Number 35. Okay. The diagram shows a wheelbarrow. Yes, here is a wheelbarrow and its load, which have a total weight of 150 Newton. Here is a 150 Newton. Here is a pivot. So distance into force will give you a turning effect. This is supported by a vertical force. Vertical force is somewhere here, and its distance is this one. You can see this force is acting, it's a weight which is acting in downward direction, and this is the distance from pivot point. So now force into perpendicular distance, and it will give a kind of clockwise, like this, a clockwise movement in it. Here is another force, and the perpendicular distance is here is a perpendicular distance, which is 0 0.75, 0 0.71.5, and the perpendicular distance. What is the value of F? So we know that clockwise movement equals anti-clockwise movement. So clockwise movement is the blue one. 150 is the force, and 0 0.75 is the perpendicular distance. So 150 times 0 0.75 is around 112.5. Approximately this would be the figure. And clockwise movement is, total distance is 1.5 and force is F. So let's move it to the other side. 112.5 divided by 1.5, which is F. So it is approximately 75. So the correct option looks A. A is a correct option. Number 36. The diagram shows the cross sections of different glasses. Which one is the least stable when filled with the liquid? Now let's compare with their center of masses and their okay, when liquid will be filled in it. So you can see in case of B, I can guess because it's you can see its base area is very small compared to rest of the glasses. And you can see if it is filled with it would be filled with water, approximately the center of mass suppose is here, then center of mass would be comparatively higher than other glasses. So that's why I do believe that B would be the least stable because of its small area and high uh, like height of the center of mass is large as compared to rest of them. Okay. A tractor is being used on a rough road like this. What is the safest position for its center of mass? Like you can see whether this would be this should be the center of mass, this would be the center of mass. Like let me mark them. One center of mass is here, one center of mass is here, one center of mass is here, one center of mass is here. So by definition we know that the lower the center of mass, the more the stable it would be. So the green one looks better because center of mass is at its lowest position. A horizontal pole is attached to the side of a building. Here is a horizontal pole, and here is the building, some sort of building. There is a pivot P. Okay, pivot P is here at the wall, and chain is connected from the end of the pole to the point. Okay, chain is connected from this to a higher point of the wall. So there is a chain from here to here. There is a tension force F in the chain. Okay, so it is like when it is connected with it, there would be a tension force in upward direction. What is the movement of the force F about the pivot P? Here is the force F. One second, one second. Sorry, I misread something. The pole is a horizontal pole. The pole is same thing like this. And there is a pivot P, okay, at the wall. And the chain is connected from the end. End is here. So chain is connected from here till here. It's a chain. Initially, previously, I thought that there would be a chain, but I was wrong. The chain is here. And this is a tension force which is in upward direction. Okay. Now, from the pivot to the chain, this is the distance. This is the distance, and the tension force is in this direction. If we multiply force into this distance, which because both are perpendicular to each other, it would be equal to moment. So this is the moment about of the force F about the pivot point P. A load is to, okay, now number 39. A load is to be moved using a wheelbarrow. Here is a load which is acting in this direction. The total mass of the load and wheelbarrow is 60 kg. So mass is actually 60 kg and weight would be 600. So weight would be 600. Pivot is somewhere here. Okay. What is the size of force F needed just to lift the loaded wheelbarrow? So from pivot to the weight, it's a distance. This distance from here till here is 700. And the force is actually the weight, which is 600. So let's calculate a clockwise movement because it will give a clockwise movement like this. So clockwise movement is 70 times 600. Okay. And then you can see there is a distance. This is the perpendicular distance, which is 120 centimeter, and force is F. So movement would be anti-clockwise movement. And anti-clockwise movement is how much? 120 is the distance and F is the force. So we know that for a balanced case, clockwise movement and anti-clockwise movement are equal. So 120 F to 6 are 12, two ones are 2, 352s are 700. So our answer is 350 newtons, which is this one. A girl uses paper clip to balance a toy bird on her finger as shown in figure. It's a toy bird and these are paper clips. What is the effect of paper clips? They help to raise the center of mass above fingers. Center of mass above fingers. That looks incorrect. They help to raise the center of mass to her finger. Like in previous case, in A, it says the center of mass above, and in second case, it says below, like on fingers. They help to lower the center of mass below her fingers. They do not affect the center of mass, but increases the weight. Yes, they help to lower the center of mass. This option looks fine. Now 41. A driver's foot presses with a steady force of 20 Newton. Okay, 20 Newton is here. And this is the pivot. From pivot to the force, distance is 40 centimeter. So it's a perpendicular distance. It's a perpendicular force. So 20 times 80 will give us, and like when you apply it, it would give us anti-clockwise movement. So anti-clockwise movement, okay. What is the force F pulling to the piston? Okay. Now the pivot is here. The perpendicular distance is from here to here is 5 centimeter, and the force acting on it from this point to this point is F. So clockwise movement is 5F. If clockwise and anti-clockwise movements are equal, then 800 so 160 Newton is the force. So we have option number D is the correct option.